Okay, here we go again with the next section. And in 16D, we have a continuation of the principles you learnt in 16C. The only real difference is that now our answers are going to include negative numbers. Now, if you're confident, you can go straight ahead and try the exercises. But if you'd like a little bit of a review of the ideas, then stay with me. First of all, it's worth mentioning that we are working with inverse operations. Now, I think in the last section I was talking about doing the opposite or doing the reverse, but the correct mathematical term is inverse. The definition of an inverse operation is that it reverses the effect of another operation. So, an example is addition and subtraction, and also multiplication and division. They are inverses of each other, just as we've been doing. Alright, so let's return to those examples. In the first one, x plus 3 equals negative 2. We are going to have to subtract 3 from both sides. I'm going to start by doing an equal sign, remembering it should be directly underneath the equal sign on the line before. And I'm going to show that I'm subtracting 3 from both sides. So x plus 3 minus 3 equals negative 2 minus 3. Now plus 3 minus 3 is 0. So on the left hand side we have x equals, and on the right hand side negative 2 minus 3 is negative 5. That's the solution, x equals negative 5. For the next one we have x minus 4 equals negative 6. So the inverse of subtracting 4 is adding 4, so we add 4 to both sides. Starting again with my equal sign, x minus 4 plus 4 equals negative 6 plus 4. Remember, you must do the same operation to both sides of the equation to keep them the same, so that they remain equivalent equations. X minus 4 plus 4 is just x, and negative 6 plus 4, well, the negative number is bigger than the positive number, so we don't quite get back to 0. Negative 6 plus 4 is negative 2, and that's our solution. In the next one, negative 2 times x equals 10. The inverse of multiplying by negative 2 is to divide by negative 2. So we divide both sides by negative 2. And on the left, negative 2 divided by negative 2 is 1. Those cancel out. When a factor in the numerator is the same as a factor in the denominator, they can be cancelled out. So on the left is x equals negative 5. 10 divided by negative 2 is negative 5. Remember that a positive divided by a negative is a negative. Example D, we have x divided by 3 equals negative 5. The inverse of dividing is multiplying, so we're going to multiply both sides by 3. On the left, 3 divided by 3 cancels out, and so x equals negative 5 times 3, which is negative 15. Now the next one, we get to a two-step solution. We have 2 times x plus 5 on the left. We want to get x by itself, so we're going to remove the plus 5 by doing the inverse, which is to take 5. And we do that from both sides. 5 take 5 is 0, so on the left we have 2x, and on the right negative 6 minus 5. We started at negative 6 and we're taking away a number, so the answer becomes more negative. 6 plus 5 is 11, but we've got negative numbers, so the answer is negative 11. Now we need to divide both sides by 2, and the factors of 2 cancel out on the left. X equals negative 11 over 2, or negative 5.5. Now in the last one we need to subtract 23 from both sides to eliminate the plus 23 on the left. And so our next line of working unit, we will have 5x equals negative 15. We're subtracting a number that's larger than 8, so the answer is going to be negative. Now we need to divide both sides by 5. The 5's will cancel out on the left, and negative 15 over 5 is negative 3. Here's a reminder of what exercises you need to attempt. Just the odd letters for numbers 1 to 4. Be methodical, be careful. Don't leave out too many steps, but you can start to do a few more things mentally. But make sure you are able to communicate and explain each line of working out.